Hey guys, how's it going? So today we're going to work on Leetcode problem number 73, set matrix zeros. It's a Leetcode medium problem. Mainly we're just going to be traversing and keeping track of indexes where we see zeros in a two-dimensional array. It's not too hard of a problem, but hopefully it'll make more sense after I solve it. So, given an m by n integer matrix, if an element is zero, set its entire row and column to zeros, you must do it in place. So all it means is whenever it says you must do it in place is that we're basically just not going to return anything. And like it says on here, it's an m by n integer matrix, meaning that it's not going to be a cube. It'll be m, which is some integer value, and then n, which is some different, or it could be the same integer value. So like here we have a zero. Um, we have a zero on the top, the sides, and then the bottom. And then that's just due to the fact that both we see the zero at from a column point of view, the first index, and then we see it from a row point of view, the first index. Therefore, we just make all elements on those rows and columns of both the first and first index zero. Same here. Okay. All right. So let's gonna get started. So the first thing we're gonna do is we need to make an array to help keep track of occurrences of an index that has a zero. So column equals zero. Just gonna initialize it for now. Zero. Okay. I'll say for row in let's call it again. Matrix for column each row. Actually, we need to access the specific indexes, so what actually might be better to do is to um, we'll fill this in here and we're going to actually get the length of our matrix. And now this isn't actually going to get the true length of our matrix like here. Technically, we have 9 elements in our two-dimensional matrix, but it's only going to return 3, that being each array within the two-dimensional array. So then we need to actually pull out the specific elements within the arrays within the array, the two-dimensional array. Um, okay, so at this point, let's say, let's change this to I, like using I and J better for J, and then, uh, the range of matrix on I. Then all we're gonna do now is we're just gonna say if, let's think, if matrix I, J equals 0, just gonna, and for the column, let's see. For the row, we're going to want to actually take, let's start with that one because that's easiest to visualize for now for me. So row is actually going to append the outer loop, which is right here, because the outer loop, you have to imagine that these are actually stacked on each other. These arrays within the two-dimensional array are actually stacked. So like 1, 1, 1, 1, 101, 101, and then 1, 1, 1, 1. And so basically that's what this outer loop controls is it's going down the actual rows and then the inner loop is actually what goes across the columns. So we're just going to do to the outer loop we'll append I and per column 0 we'll append J. Okay. Now what we're going to want to do is we're actually going to want to loop through this again. And essentially what we'll do here now is we're just going to identify all of the indexes where these zeros occur, and basically we're just going to loop over them in order to try and replace the values of what might be there with 0. So we'll get the row length. Let's get the row length, which is going to be, let's see here, row length is just going to be the length of our matrix. And then the length of our column is going to be set equal to the length of our matrix, and then just some array in here, and they all should be the same length for the columns because it's m by n, meaning m is a certain length and n is a certain length consistently throughout the two-dimensional array. All right. So now what we need to do is we need to actually loop through all of these values that we have indexed in our call zero and row zero. So to do this, we're going to say for I for row and what's the length of the range for the length of our rows. Um, So now we need to actually iterate over our array, which contains the rows that are indexed as to need to have be zero, basically. Now we'll say for I, which now would be good time to use I as an index. I in row for zero. Yeah, we don't need a range there because we're just going to iterate over it. Because it could be different. Like we could have an index of zero and an index of two, therefore we don't want to necessarily get the range of that. And then we're going to say matrix row I, so I'm going to say equal to zero. Alright, now we need to do the same thing for a column. So for column, put the range, you know, column. For I, same thing here. Column, matrix. Alright, so basically here we're going to want to do I column. Let's run that. For I, oh, I forgot to put range. Yeah. I in. Oh, I'm sorry. That should be the range. Because that's not in our that's missed this. This actually should be for sure zero because those are the actual columns that we're indexing over that have this. Listing links that are full column, and range of call, and we should replace this. This part all here. Submit it. So I'll explain what happens there. Very awesome. So runtime beats 51% of users and memory beats 61% of users. So that's awesome. So I'll explain to you what happened there. Basically, I wasn't thinking about it necessarily from the standpoint there of going from the really taking the column itself and matching it with a row. I was more so trying to do it like with a column with another column. So that's kind of what I forgot to do there. I wasn't really thinking about that for some reason. But yeah, I hope that you guys liked the video. And if you guys have any questions, just let me know. Thanks for watching.